Today is day 18 of our CCNA 200-301 course, and today we're going to be covering DHCP, DNS, SNMP, and Syslog. What is DHCP and DNS? Let's search it up. DHCP is used to assign IP addresses to devices on the network, while DNS is used to translate domain names into IP addresses. DNS maps the domain names to IP addresses, whereas DHCP is a mechanism that allocates the IP addresses to the hosts in a network, either statically or dynamically. So, DHCP. DHCP automates the assignment of IP addresses, subnet masks, default gateways, and other network parameters to devices on the network. This ensures that each device has a unique IP address and the necessary configuration to communicate effectively within the network and beyond. So, how it works. There's these four things, and this is how it happens. So, there's DHCP discovery. When a device or a client connects to a network, it sends out a DHCP discover broadcast message to locate a DHCP server. DHCP offer is the DHCP server responds with the DHCP offer message, which includes an available IP address and other configuration information. DHCP request is what happens when the client responds with the DHCP request message in indicating that it accepts the offer. Then after that is DHCP acknowledgement, which is when the server sends a DHCP ACK message to confirm the lease of the IP address to the client along with the lease duration and other network settings. So this is how they communicate in creating a DHCP IP address. DNS is what translates human readable domains like say www.google.com into IP addresses like 192.0.2.1. And this is what computers use to identify each other on the network, right? IP addresses. But DNS makes them into names so we can read them. This system enables users to access websites, services using easy to remember names instead of numerical IP addresses. So how it works, similar. Domain name resolution, these are like its functions. So, when a user enters a domain name in their browser, the DNS client or resolver queries a DNS server to resolve the name into an IP address. DNS query is when the resolver sends a query to the DNS server, starting with a recursive resolver, often used like given by the user's ISP, Internet Service Provider. Then after that, recursive querying, which is that the resolver may query other DNS servers like root servers and top-level domain servers and authoritative name servers in a hierarchical manner to find the IP address corresponding to the domain names. So think of it like this. You're trying to get into www.kittenst-shirts.com, but to do that, you need to go through kittens.com and then the kittens clothing and then t-shirts. So it's like one domain server to the second domain server to the third server. One has the kitten domain, then the kitten's t-shirts domain, and then the kittens whatever, right? Hope that makes sense if that was not a lousy analogy. Then after that, there's a response, which is once the IP address is found, it is returned to the user's device, enabling the browser to establish a connection to the web server associated with that IP address. So basically, DHCP automates IP address assignment and network configuration, reducing the needs for manual setup and preventing IP conflicts. DNS converts domain names to IP addresses, making it easier for users to access network resources and using memorable names instead of numeric addresses. Because you have to imagine this. Imagine there wasn't any type of thing like Facebook.com, and instead you had to memorize like 192.168.22, right? And then there's like 100 other websites. That would be terrible. That's why DNS is super convenient in this world. So, what is SNMP in network operations? SNMP, or Simple Network Management Protocol, is a widely used protocol for network management. It allows network administrators to monitor, manage, and configure network devices such as routers, switches, servers, printers, and more. So, we're going to go deep into all these and their SNMP's purpose in all of these and like their operations. So, let's do this. Monitoring. SNMP enables continuous monitoring of network devices to ensure they are functioning correctly and efficiently. It collects various metrics and status information such as CPU and memory usage, network traffic statistics, device uptime, error rates and packet loss, and interface status. And SNMP also provides management. It gives tools for managing network devices, and administrators can change the configuration of devices remotely, like modifying IP addresses, adjusting routing tables, and changing device settings. Fault detection and notification is also an ability of SNMP, and it helps in detecting and notifying network faults. It also supports trap messages, which are alerts sent from devices to the management system when certain conditions or thresholds are met. So like a device goes offline or a critical error occurs. This allows for a quick response to performance issues. It can also give you performance analysis and like the basic thing, like collecting and analyzing performance data. SNMP helps in identifying network bottlenecks and understanding usage patterns and planning for capacity upgrades. It aids in ensuring that the network performs optimally. So, how does it work? SNMP operates using a client-server model where the client SNMP manager communicates with the server SNMP agent running on network devices. Here's how the communication typically happens. So, SNMP manager, this is the central system, and what it does is manages network devices. It sends requests to and receives responses from the SNMP agents. SNMP agent. So what is it? It is a software component that runs on network devices. It gathers and stores management information and responds to requests from the SNMP manager. Then there's MIB, which is management information base. This is a virtual database of network management information. Each device has its own MIB, which defines the parameters that can be managed or monitored. So, SNMP offers several basic operations, including GET, which is the SNMP manager requests information from an SNMP agent, and it's GET next, and that's where the SNMP manager requests the next object in the MIB hierarchy. Set, where the SNMP manager changes the value of a parameter on an agent. Trap, where the SNMP agent sends an unsolicited alert to the SNMP manager indicating a significant event. Or get bulk, which is the SNMP manager requests large blocks of data from the SNMP agent. So there's versions of SNMP, each with different features and security levels. There's V1, V2, and V3. So V1 is the original version providing basic functions and features with limited security, and SNMP V2C is an enhanced version with improved performance and additional features, but still has pretty bad security. And then SNMP V3 is the latest with good security features, including authentication and encryption to make sure that the data is protected when it's being transmitted. So, what is a summary of SNMP? It is essential for monitoring, managing, maintaining network devices. It allows for automated fault detection and performance analysis, contributing to efficient network operation. The protocol uses a manager-agent model with communication facilitated by MIBs. Different versions of SNMP offer varying levels of functionality and security, with SNMP v3 being the most secure. By using SNMP, network administrators can ensure that their network infrastructure runs smoothly, efficiently, and securely. So, that's it for SNMP. Now we move on to Syslog. Syslog is a standard protocol used for logging messages from network devices and computer systems. It provides a way to collect and store log data, which can be critical for monitoring system activity, troubleshooting issues, and maintaining security. Here's a detailed description of Syslog features, including facilities and levels. So we're going to cover message format, centralized logging, flexible configuration, and compatibility. Let's do this. Message formatting. So, Syslog messages have a standardized format that typically includes the following components. There's a timestamp, which indicates when the log was generated, a hostname or IP address, which identifies the source of the log message, facility, which specifies the subsystem or application that generated the message, severity level, which indicates the importance or urgency of the message, and then message content, which contains the actual log message or event description. There's also centralized logging, which basically has given the Syslog the feature to allow devices to make their log messages to a central Syslog server, and this centralization makes it easier to manage and analyze logs from multiple sources. So when it gets logged, you can manage and analyze logs from many places instead of one because it's a centralized spot. There's also flexible configuration with Syslog because it allows administrators to define which messages should be logged, where they should be sent, how they should be stored. So this can include local storage, remote servers, or even specific log files based on the message content. There's also compatibility because Syslog is widely supported on lots of devices and various operating systems. So it makes it a versatile tool for logging into heterogeneous environments where it's like mixed, like there could be Cisco and other softwares and stuff. So it works for that. And compatibility is important because you can have many different types of environments, and it's good for anyone, anytime. So, facilities. Facilities in Syslog are codes that represent different types of system processes or applications. They help categorize log messages by their source. Some common Syslog facilities include 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 to 23. Now, you guys can read all that because that is a lot of speaking. But honestly, just know the basics. I don't think this is too important, in my opinion. Yeah, you won't really need much of this. Just make sure you know the basic. It's kernel messages, user level messages, mail system daemons, and whatnot. Syslog severities. This is what you need to know. So, severity levels in Syslog indicate the importance or urgency of the message. These levels range from 0 to 7, with 0 being the most critical. So it goes from 0 being the most critical to 7 being the least. Remember this. So, the levels are 0, which is emergency, and the system is unusable. 1 is alert, where immediate action is needed. 2 is critical, where critical conditions are happening. 3 is error, where there's error conditions. 4 is warning, where there's warning conditions. 5 is notice, where it's normal but significant conditions. 6 is informational, where it's just informational messages like, hey, you got to update. And then 7 is debug, where debug level messages typically used for troubleshooting. So, how it works. Syslog is an essential tool for system and network administrators, providing critical insights into system operations and helping to maintain security and performance. So what it does is message generation, where application system processes and network devices generate log messages and assign appropriate facilities and severity levels. Then there's message transmission, where the messages are sent to a Syslog daemon it's on the system or a remote Syslog server. Then there's message processing, where the Syslog daemon processes the messages according to configured rules, which may include filtering, prioritizing, and formatting. And then there's message storage, where the processed messages are stored in log files, databases, or other storage systems for later analysis and review. So let's go through practice questions. Explain the roles of DHCP and DNS within a network. How do they differ in terms of their primary functions? So read the questions, pause the video, and tell me if it's A, B, C, or D. The answer is A. DHCP automates the assignment of IP addresses to network devices, while DNS resolves human-readable names into IP addresses. That's correct. So, practice question 2. What are the primary functions of SNMP in network operations? Describe how it operates using a client-server model. So, is the answer A, B, C, or D? The answer is B. SNMP enables network monitoring and management by using a client-server model where the SNMP manager communicates with SNMP agents on network devices. Then there's practice question 3. What are Syslog facilities and severity levels? Provide examples of both and explain their importance in Syslog functionality. So it's A, B, C, or D. This is a very difficult question. If you understand this, I'm thinking if you can easily do this, you are in great shape for the CCNA. So answer is A. Syslog facilities categorize log messages by their source and severity level, indicate the urgency, helping prioritize and manage log data effectively. So that was it. Hope you did good on the quiz. And I hope you liked these videos that I'm posting. If you want to share support for the series, please like, comment, and subscribe. Thanks for watching. This is Daud N. See you soon. Goodbye.